Yeah, okay.
So again, welcome Ravi to IIT Kanpur. He has been Secretary to Government of India at Ministry of Earth Sciences since October 2021. He has, of course, a very illustrious career. He started as scientist at Indian Institute of Tropical Meteorology, Pune, from 1998, and he worked there until 1997. After that, he moved to National Institute of Ocean Technology, where he worked from 1997 to 2001. As you know, that's another laboratory of this ministry in Chennai. And after 2001, he moved to Indian National Center for Ocean Information Sciences at Hyderabad. Later on, he became director of that place as well. And in between, he also worked at NCPOR prior to joining the ministry as secretary. He is fellow of all major academies, including Bangalore, Allahabad, as well as Engineering Academy. He is also member of Norwegian Scientific Academy for Polar Sciences, and he is also fellow of Indian Meteorological Society, Ocean Society of India, and Indian Geophysical Union. So it's a great honor to have Ravi here to give a talk on blue economy, India's opportunities and challenges. So you have about an hour. Thank you.
Thank you, Professor Tripathi, for inviting me for this, first of all, IIT, and also make this important topic, blue economy. I see that this IIT Kanpur is not much work is going on in blue economy. Initially, I was thinking of giving some talk about general earth sciences with the various spectrum, how we need to do what we need to do. Then I thought, okay, maybe I will start with the blue economy. So because it is not started yet, so that's the idea we started. I thought of it. So the basic intention of this talk is basically when you talk about India envision the Viksit Bharat. So each individual, each group of people, as well as the ministries and societies, looking for how do we contribute to the mission of 2047. So in that aspect, in the Ministry of Earth Sciences, we have made some of the few areas we need to contribute for the Viksit Bharat. So one of the aspects is in the blue economy, how we can growth, that means the GDP, the presently roughly about 4% of GDP comes from blue, that means from the ocean. How do we double it or double digit we bring it? So what are the opportunities are there? When you navigate various opportunities, then what are the challenge in that along the path? So that is what I want to just tell some of the areas where we need to focus so that we can have a more and more what is called GDP growth. That's the main objective, this one. So, thank you again for bringing out this important lecture series, Swastibhavatu. So, that lecture series, and I will just talk about what are the in general in ocean, what are the opportunities are there, and what are the challenges are there. Then I will talk about little bit of various resources, especially living resources and non-living resources. Then how the blue economy has come. Most of you know that blue economy means it is ocean economy plus sustainability. That is what blue economy. So how the blue economy, we need to nexus between the resources, sustainability, and the various hazards come from the ocean. And what we need to do, the way forward. And finally, one of the pilot project of blue economy for our ministry is Deep Ocean Mission. So I will highlight what is the Deep Ocean Mission about. That I will end with that. So before going to that, many of me may be knowing that what is the Ministry of Earth Sciences. Of course, Ministry of Earth Sciences, we have 10 institutions, and the color code indicate various state of matter. Of course, the light blue is atmosphere, the dark blue is ocean, and the orange one is a solid earth. And one is blue and white, that is ocean and cryosphere. So these are the 10 institutions are working. Basically, we try to understand the Mother Earth, how the ocean processes or atmospheric processes are happening, and process understanding, and how it is talking to each other. That means how atmosphere is talking, hydrosphere, at what time scale, and how it is happening. Similarly, each sphere, how it is talking each other. What is the symbiotic relation between these spheres? And for this, what we do is we observe the Mother Earth at the different spheres, and we collect the data. From the data, we generate various knowledge. From the knowledge, we translate to information. Then finally, we provide various services. That is our objective. So basically, we call it SQ, that is do science, then translate that science to the services for the benefit of society. That is our overall objective of the earth sciences. So just I will dive into the ocean. When you talk about the ocean, just before you should, many of you, maybe the setting the things, maritime jurisdiction when you talk about. So up to, from the coastline, our high tide water coastline, up to 12 nautical mile, air, water, solid earth, all belongs to the country, particular country. Suppose in India, if you have a coastline up to 12 nautical mile, all this air, water, and solid earth belongs to the particular country. Then up to 200 nautical mile, air is free, that means any aircraft can go, but water and solid earth belongs to the country. That means fishing resources or any other resources in the ocean or any other resources in the solid earth like mining or minerals or oil and gas, it belongs to the particular country in 200 nautical mile. Beyond 200 nautical mile, then up to 350 nautical mile, that is a continental shelf, there only solid earth belongs to the country, whereas the water and air anybody can use. You can do fishing or you can travel by air or whatever you can do. And beyond 350, it is called high seas. In the high seas, all belongs to the global common. It is governed by the International Seabed Authority for Mineral Resources, and there is some new things are coming. It is called BBNJ. It is a biological resources beyond national jurisdiction. It is called BBNJ, means biodiversity beyond national jurisdictions. Still, that has to be implemented by India. Of course, it is just started. We are signatory, but we have to amend it. Maybe the next parliament, it will be taken amendment. Then we will be the signatory to the BBNJ. So this is the overall objective. It is governed by the UNCLOS. It is a United Nations law of the sea, and they governs. So International Seabed Authority is in Jamaica. They usually govern the mineral resources in the high seas, and the CLCS is nothing but continental shelf. 200 to 350, it is not everybody will get it. If you are to prove, if this area, that means 200 nautical mile to 350, if the sediment thickness is this much and it belongs to your sediment, you have to scientifically you have to prove it. If you prove it up to where you are proving, you can get. suppose sediment thickness should be up to this much. Suppose 1 kilometer sediment thickness should be there. That means if you have up to 400 nautical mile, you have a sediment thickness of 1 kilometer, then you can get maximum 350. But if you have only 250 nautical mile, then you will get only 250. Maximum you can get 350. That's the idea. So this is the overall maritime jurisdiction where we have to govern in the ocean area. So when you talk about the future priorities, when earth science, how we can contribute, so always you can see that we have to have a sustainable resource management, and we need to have a preparedness for the disaster, and also we need to take care of the climate change and productivity of agriculture, public health and air quality. So various aspects are there. But in general, when you talk about overall future, when you talk about, I personally feel that energy, water, food, these are the three fundamental which everybody is looking for finally. Now of all these three, then there is a health. Health means health of the human being as well as health of the ecosystem. That means one health. So the health, energy, water, food. So any research you do for everything, that is the only four aspects you will be coming into that. And these four aspects, how it will be changing over the period due to climate change. Suppose if it is a warming trend is happening, how the energy things will be changing. So that is the aspect we need to look at it. And then apart from that, hazard mitigation, how do we prepare for the various hazards from the planet Earth, either it is from the ocean or from the land or various hazards, how to mitigate. And also we need to keep in mind that it is the resources or anything, whatever you are tapping, it is not only for us, it has to be future generations. So we need to keep our sustainability also in mind. So first I will tell ocean as a oceans of opportunity. So first and foremost, of course, it is more than 72% of Earth's surface, it is ocean, and it is a life support. Many of you know that half of the oxygen comes, what we are breathing, comes from the ocean because of the phytoplankton. That means every alternative breath, what we are doing, it comes from the ocean. And also it is act as the largest carbon sink because of the phytoplankton or various other plant, that means fauna. And the food security, of course, ocean feeds us. It is not only fisheries, but also various kinds of seaweeds and other things. So we get around fisheries, roughly about 1% of GDP for our nation, comes from the fisheries alone. And of course, other economy such as maritime transport, maybe the shipping, and tourism, and non-living resources like minerals, energy, and other things. And also we have a climate. When you talk about climate, without ocean you cannot talk. When you want to have weather prediction, for few days you have to depend on the atmosphere. But beyond 10 days or maybe 7 days, you have to predict. That means you have to depend on the ocean. As you go below the depth, that memory will be more. Suppose you want to have a seasonal prediction. So you have to have at least mixed layer depth ocean. Then only you can go for seasonal prediction. So that is why when you are talking about climate large scale, decadal scale or long-term projection, all depends on the ocean. So that is why we have to have basically it is a regulator of the weather patterns. And of course we need to worry about the defense, security as well as the coastal production of various kinds. So India is having a more than 2.2 million square kilometer of EEZ area, and also we have more than 11,098 kilometer coastline. Of course, it is recently revised. Earlier, you maybe noticed that it is 7,500. Because of the segment length, it has been definition is changed. Now it is a small segment. Because of that, it has become 11,098 kilometer coastline. And it is also strategic trade routes. Now you know that Indian Ocean is the highest trade in these ships. Roughly about 10,000 ships per month it will be traveling around the Indian Ocean, just below the Sri Lanka. And it has 12 major ports and 200 minor ports, and there are many intermediate ports are there. Though it is there like this many things, but only what we know from the ocean is very little. Especially in the deep ocean, we have only knowledge about 5% of the deep ocean only we know. We don't know much about ocean physics or chemistry or biology or any other things which we don't know. And as per the global things, SDG 14, it's a sustainability goal 14, life below the water is global mandate. And now this decade is a UN decade of the ocean, basically to understand the ocean behavior and what we need to do from the ocean, how a healthy ocean or predicted or protected ocean can be. For all these things, the UN decade of the ocean. And the national mandate, of course, 2030, one of the 10 core dimensions, or maybe what is called core dimensions of the growth has been set by the country. One dimension is the blue economy. So these are the importance of the opportunities. When you talk about opportunity, there are a lot of seas of challenges. When you talk about challenges, first challenge is a climate stress. What are the climate stress? You have a sea level rise. It is every year it is rising. And what is the coastal erosion and ocean warming, marine heat wave, and also the increased intensity of the cyclone. Cyclone may be the natural, but the increased intensity and the frequency changes, it is due to the climate change, and coral health degradation, and mangrove loss, and also ocean acidification. So these are all climate stresses ocean is facing, and non-climatic stresses, especially natural hazards, and also marine litter and pollution, it is man-made, and over-exploitation of resources like fisheries and other things, oil spills, saltwater intrusion, especially in the coastal regions. And there are other what is called challenges. It is a resource. What are the resources? Where it is available, we don't know still. So we need to map the resources, and also technology to harness. There are resources, but we don't know how to, we don't have a technology to harness. So that is why we have to be more technology challenges are there. One or two I will highlight, and then mitigation measures for various stress, and what is the policy, because we don't have many things, our policy is not there. Even India, up to last 3 months, we don't have a policy of deep sea fishing. So now only it has come, the deep sea fishing policy. Similarly, security and international collaboration and geopolitics and geostrategy, because ocean space is an important geostrategy. And finally, when you want to do all these things, we need more and more human capital. Whether we have that much capital, human capital, no. So that is another challenge. So all these things, when we do challenges, and also we have to always keep in mind the sustainability. So now I will give each one slide about each resource or whatever the things, what are the opportunities are available. When you talk about the food, first and foremost, we need to do for deep sea fishing. See, most of our coastal population, coastal fisheries are only harvested in the 20 nautical mile. They don't go beyond 20 nautical mile. But our resources are there plenty. So, but unfortunately, we are not able to tap. So that is why we need to go for deep sea fishing. And that is now the policy has come. It is a rebate is announced. Now there is a loan. Many things are being announced in this budget for the deep sea fishing. And also deep sea aquaculture, that is another important area, we need to dive on it. And cage culture, this type of cage, you keep the cage in the ocean about maybe few tens of meter diameter, so that you initial fish you can put it, then it will grow only in the natural water, but it can grow, it cannot go away from that. And similarly, we can have algae harvesting and various things you can think about. And seaweeds and seagrass. Seaweed and seagrass is one of the important things which India is unfortunately not tapped at all. Indonesia has biggest, what is called, more than 5% of GDP comes from only seaweeds and seagrass. Because we are in the tropical waters, we are fortunate to have more and more seaweeds can grow, but we are not growing because we were not knowing much about that. Now from the seaweeds, people are able to do, HPCL already developed a crude oil or from the seaweed. And also some of the seaweeds you can have eat edible, and some seaweeds we can make a crude oil, and indirectly these seaweeds grow, then more and more carbon absorption. So carbon indirectly you are going for carbon sequestration. So that much benefit is there, not only seaweed but also in the seagrass is more carbon will uptake. And also we need to have many other technology, fish aggregation device, cold chain infrastructure, because the coastal area we need to have a cold chain infrastructure which have never built, and associated fisheries infrastructure, and post-harvest management we have not planned it, and marine culture activities we need to we have to start more and more like that. And another important thing, Southern Ocean fisheries. India is signatory to Antarctic Treaty. We have put a station in Antarctica only to harvest the Southern Ocean fisheries. There are two important fish is called, one is grill fisheries and another one is tooth fish. These two fish are very costly, and the grill fisheries, omega-3 contents are very high. And every country is having only quota. This much only we can do. But every country is fighting for the quota, but only India, we are not going at all in that. And it is a very rich, and it is, what you can say, you take a grilled fish and you just squeeze it, you can get omega-3, that much. It is a food for the, what is called penguin and other things, but it is a rich resources. The ecosystem wise, the rich ecosystem in the entire planet is Southern Ocean. So that is why we have to have a Southern Ocean fisheries also to be activated. So this is a marine living resources, various activities, what are the opportunities are there. The next I will come from energy. If you talk about energy, in the ocean, there are plenty of energies available. You can have a floating solar panel. Oh, there are solar panels come, just you throw it like a tarpaulin. You can get a 1 kilometer tarpaulin, you get to solar panel. It is wave rating solar panel, so you harness the energy from this offshore solar panel. Singapore, 40% of the energy for Singapore, it comes from the offshore solar panel. Then we have a salinity gradient. Wherever the river meets the ocean, the gradient between the salinity is more than 20 PSU. If you have a more than 20 PSU, then you can generate the osmotic pressure. From the osmotic pressure, you can generate the power. And of course, tidal energy, and then ocean current energy. Wherever the currents are very strong, especially in Andaman Sea, and also some of the East India coastal current and West India coastal current, you put a turbine under below that, then you can produce the ocean current. Then ocean thermal energy, similar to the salinity gradient. If you have a temperature gradient between the two, that means 20-degree temperature gradient, if you have, you can produce the energy, ocean thermal energy conversion, OTAC they call. And also you can produce wave energy and maybe the offshore wind energy, because the offshore wind energy is 10 times superior than the land wind energy because of there is no what is called friction. So you can get more energy in that, and also the density of the air is more moist, so the density is more, so energy production also will be more. So now India is going for, in the southern coast, roughly about, I think 2 gigawatt power plant is going in. Just to 3, if you put it, you can get to 3 gigawatt in this offshore wind. So these are all various energy we can make it. Apart from that, we have what is called gas hydrates in the east coast. Gas hydrates is a solid form, the liquid form, compressed, it is available below the seabed, but unfortunately we are not able to take it because we don't have technology to tap it. So that is countless what is called gas hydrates as the methane, and there are about various what is called policy enablers. We have to do it, because when you are taking about energy harvesting, so it is a state government, what is called under their business rule. So that means state has to allocate some space. Okay, this is for energy farm, this is for seaweed farm, this is a what is called mangrove farm, like that. So we need to define marine spatial planning, like urban town planning. We need to have a marine spatial planning. So I think the INCA is first we have done now the spatial planning of energy, where you will get what energy in which season. That has been made. Now we have to go for another food and other things, so that we can have a spatial mapping. That is more important, which we need to do. So various things, some technology is available, but many of the technology, yes, economically feasible, but some technology, the present technology economically is not viable. So we need to have some other technology, or maybe fine-tune efficient way of harnessing, so that we can meet the demand of the land, whatever the things. That is another aspect which we need to think about. And the third one is freshwater. The freshwater, the conventional desalination plant is basically, it will produce lot of brine in the sand, in the land. So because of that, the land degradation of the soil and other things, or groundwater discharge, groundwater will become saltier. And to avoid that, I think NIOT recently had developed a technique. This is very simple technique, like what I was telling about ocean thermal energy. Basically, if you have a 28-degree temperature water, the water will boil at 100 degree in the atmospheric pressure here. But if you reduce the pressure by 7 times, the water will boil at 28 itself. So you make a tank, you take a seawater and put this much big tank, put a seawater, and then you reduce the pressure, this will evaporate. The evaporated water you take it and condense with the evaporated water. With the subsurface cold water, it is about 5 degree or 10 degree. You just cold water you put outside, so you will get a condensed water. So that is become the fresh water. So in that process you will get many benefit, but this type of plant already established all along the Lakshadweep. So roughly about I think 8 plants have been established, I think 1 million liter per day. Now I think we are planning to do with same thing with the ocean thermal energy, because once the water is evaporated, it is coming out from the steam type, then you put a turbine there, so that turbine will produce the energy. That energy you can utilize that one. So ocean water as well as energy, both you will get. It is not enough. The water what you are bringing from the subsurface about a kilometer's depth, that water is having a nutrient rich water. The nutrient rich water, you take it out and put it into the surface, you will have a more and more nutrient rich water at the surface. So India or maybe the tropical region is having plenty of sunlight, so you will have a phytoplankton growth is much more, so that you will have a fish productivity also is more. So in one plant you can get energy, water as well as phytoplankton growth. But we have to think about when we are bringing it 1 kilometer deep water to the surface, is there any ecological problem that we are working on it? Whether it is some microbes we are bringing from the subsurface to the surface, whether that will damage, it will create any other issue, that we need to work out. Then we got the next one is the minerals. So the minerals in the deep sea, basically there are 3 type of things which we will be getting in the deep sea. Basically one is a polymetallic nodule. It is like a potato type, it is in the seabed, it will be available, that is a photograph of polymetallic nodule. So if you bring that nodule, you will get 3 material mainly, which is cobalt, nickel, actually 4, cobalt, nickel, manganese and copper. These are the 4 extraction you can get it. It is a very much plenty of things are available in Indian Ocean. Here only the one problem. Now we have developed the mining machine to go there and take it out this one, but unfortunately economically it is not possible, because we have to pump in a large volume. So now 6 kilometer deep we have to bring the pumping of this mineral, or that is a very Herculean task. NIOT is trying up to 2 kilometer they tried, they are successful, but now they have to go for up to 6 kilometer. At the parallelly we have to go for environmental inspection also, whether you are damaging environmentally any aspect, that also we need to think about it. The second one is a polymetallic sulfide. It is basically wherever the mid-ocean ridge is there in Indian Ocean or any other ocean, there the what is called continental drift. So it will be just opening up some places. At that places, the water will be gushing out. So that water might have gone from somewhere and it is coming out gushing. While coming out, it brings lot of minerals, including gold, silver, multi-metal they call. It comes as a multi-metal. Then it is like a what is called fountain, it will fall around the region. So we need to identify where this polymetallic sulfide location, and then we have to make it what is the estimate available, then we have to dig this one. Of course, we have already identified this one of the Deep Ocean Mission project. We have identified 4 such locations in the Indian Ocean, and we are also asked for many other locations from the International Seabed Authority for estimating various polymetallic resources. And the third one is a cobalt crust. Whenever there is a small seamount is available in the deep ocean, so mostly it will be formed as a cobalt crust. So that cobalt crust, it is also in the deep water. So we have to get it done, that the cobalt crust. So we have applied for International Seabed Authority that region to give it for us for lease. So hopefully in a year or so we will get it that lease. Once we get it, then we can go for exploration purpose. Minerals. And also once we get the minerals, all the 3 we know how to translate or extract for metallurgical things which you have done. IIMT Bhubaneswar, they are able to make it from this metal to this PMN or polymetallic sulfide. From that, how to convert various metals they are able to do from their industries. And another aspect is shipping. Of course, as I mentioned that maritime shipping is very critical. Unfortunately, it is a semiconductor and the shipping, we are the very late we have got up. Actually, we should have started very long back, many shipping port and other things, because India is fortunate to have a maritime trade route, but we have not harnessed that trade route, various aspects. As I mentioned, about 10,000 ships per month it will be traveling just in the Indian Ocean. And what we need to do is we need to go for, I was mentioning about optimum ship routing. Maybe some of you can do that. See, optimum ship routing means ship is nowadays going from straight line. Suppose Chennai to Singapore, they go straight. But whether wind, wave, currents, nobody bothers, just to go straight. Instead of that, if you are able to use the currents as well as winds and waves optimally, or you do it, that means this much drop is the ship, and then you can calculate, then instead of going straight line, you may have to go like this. Then you will be reaching 5 days earlier than, or maybe 20% time saving, accordingly fuel saving also will be there. So we need to think about optimum ship routing. And also India is the only country where you have a coastal current 6 months towards one direction, another 6 months in another direction. In the East India coastal current as well as West India coastal current. Whether this coastal currents we can use for tropic. That means maybe one season if you want to come from Calcutta to Chennai, you want to bring some 10,000 container. So you can, without any energy, you can bring it during October to March. But in other season, you can bring it from Chennai to Calcutta. Similarly in the West Coast. So why we cannot use that type of things in the coastal, what is called transport? Because why we have to do coastal transport is a three benefit. One, because if you transport 1 ton of material by 1 kilometer, you require roughly about 100 rupees in bus or transport like a lorry. And if you are by road, but if you are transporting same thing through by train, you will be spending 10 rupees and 10 gram of carbon. Earlier cases, 100 gram carbon you emit. But if you use in the ocean, you require only 1 gram of carbon and you require only 1 rupee, especially in the East India coastal current and West India coastal current. So why we are not utilizing? So we need to utilize, that is the opportunity. But only thing is we need to have an optimum ship routing and also the timing when we are to do our various seasons we need to think about. And coastal ecotourism. As I mentioned that India is having a rich diversity, biodiversity in the coastal region. It is having geo-heritage, various geological parks, many things are there. But unfortunately, not even one oceanarium we have. If you want to see oceanarium, we have to go abroad. India is having such a long coastline, we have to develop some oceanarium, coastal heritage, so that why we cannot do a marine heritage as well as a nature-based tourism inside the ocean or outside. And also we have to have a various game like snorkeling, diving. Of course, some portion is there in Lakshadweep, but it is very minuscule. But we need to develop all along the coast. And similarly, we have to have a blue block beaches accreditation and various other sustainable development we need to do. Main thing is a geo-heritage park, which is nothing is available. We need to develop a geo-heritage park all along the coast. So that's why we can attract, this is one of the beautiful coastal tourism we can make it, but we have not utilized the coastal ecotourism. Then the marine trade and services. Marine trade means basically marine manufacturing. Even if you take small things, we are just importing shipbuilding, we don't have proper shipbuilding, we don't have boat making, even for a fishing net as well as fishing hook, we are importing from China. We don't have small industries all along the marine coast. We need to develop a marine, what is called MSME, all along the coast. That is why that MSME, we need to think about what we need to do for ease of doing business. We need to have marine spatial planning, where we need to build various, what is called shipping, shipbuilding as well as boat making places. We need to think about that line also. Then the blue biotechnology, it is a marine biotechnology. As I told that India, tropical waters having a rich biodiversity in flora and fauna, and we have a lot of already, there are some molecules they brought with various what is called medicinal values, but we need to go for a little more, because now, as I mentioned, that BBNG and other things are coming. Before that, we need to develop various drugs from the sea. Of course, there are now the deep ocean mission, more than 120 institutions are working drug from the sea alone, from India now. And also we have, as I mentioned, that algal potential, we need to tap it, and various components, maybe not only pharmaceuticals, but also various food and other things also we can, including seaweed and other things also we can develop. And also Government of India has started bioeconomy. So the bioeconomy main ingredient is a blue economy. Without blue, they cannot do bioeconomy. So it is one-to-one, it is complementary in nature. Then of course maritime security and international engagement, because the ocean is not many things, it is one ocean. So we need to work with others, at the same time we need to protect it. So what is the protection mechanism, whether underwater awareness, whether we have that much, we need to have more and more underwater awareness about, especially in the all along the coast, we need to do that. Of course, NSC, National Security Council Secretariat, already they are doing it. And we need to have international cooperation in various domains, and the CLCS, as I mentioned, that what is called beyond national jurisdiction, where we have to involve in various aspects of ISA and BBNJ. And we need to develop various indigenous technology. And also when we have made the technology, suppose the water I was mentioning, that is unique technology as developed by NIOT. Why we cannot give it to Mauritius, Maldives, and like small island nation as a global South leader? We need to do that type of goodwill things, or especially for the islands and other things. So these are the various international collaboration and maritime security we need to think about. Then finally, we need to have innovation and R&D and technology adaptation, because we need to develop various technologies and innovation. So that is why this deep ocean mission has born one of activity. And we need to have more and more industry, academia, as well as national labs, partnership has to be there, incubators and many other things we need to start up. And also we need to have a synergy between different ministries, because this is blue economy is not one ministry, but it has to be at least 10 ministries: shipping, fisheries, environment and forest, Ministry of Statistics and Planning, because they have to calculate the GDP, Ministry of Earth Sciences, Ministry of Renewable Energy and Jal Shakti. So all the ministries, some about 12 ministries are involved. So we are all working together for making this blue economy to reality, as well as the policy to be in place. And various other things also we need to develop for the innovation. And of course we need to have a human capital. The amount of ocean we have, the coastline and the area, the amount of oceanographers are very less in the country. So we need to develop more and more oceanographers, especially for technocrats. It is not necessarily oceanographer, but the technological people are required for the ocean related things to harness, as well as sustainability. So this is what we are looking at the policy vision. Basically, we want to have a sustainable utilization of blue economy resources for economic growth of the country, ensuring health, safety and diversity of the ecosystem. So we need to harness the blue GDP. That means, as I mentioned, that we need to at least to double the present one, and we need to have a sustainability in place, and also we need to have a science-based solution. I was telling about marine spatial planning. We have already done 2 states for marine spatial planning. The implementation is going on. So all along other coast, 9 coastal states as well as the 4 union territory, we need to do such a marine spatial planning. And as I mentioned, that it is an interministerial problem. It is not a single ministry can do everything. So this is what the key deliverables under the blue economy policy, if it comes, that means to double the share of blue economy and convergence and integration of interministerial decision making marine sector, and also data and science-based decision making. And finally, we need to have a resilience, basically mitigation of various marine hazards, either it is tsunami, or it is cyclone, or a marine heat wave, or harmful algal bloom, or many other things. So these are the various requirements for this one. Of course, we need to resource mapping and technological innovation we need to do various things, and mitigation strategy and policy. This is one of the important things. India, we don't have many policies we need to bring it. Like just now I told about deep sea fishing policy. Like that, we need to, various ocean sector, we need to have a more and more policy framework we need to make it. And finally, we need to have a human capital. So this is a way forward according to me. That means we need to observe the ocean, we need to have a both in situ and satellite observation, we need to observe in the entire ocean column, and we need to develop marine spatial planning for the entire sector, and we need to identify various resources, not only living but also in the non-living resources. For that we need to develop various technology and infrastructure for port modernization, especially Sagarbala and cold chains. We have to develop more infrastructure. That is why, if you may be knowing that Car Nicobar infrastructure is started mainly because of that. And also we need to have a blue finance. Of course, we need to have a blue finance for PPP models and investment incentives. And also we need to have a mitigation of various ocean hazards and ecosystem based solution. So finally, we need to have a clean, healthy and resilient ocean, as well as the productive and predictive ocean, safe and accessible ocean. Of course, we need to have a unified approach to harness the ocean responsibly for India's growth. But for this, we need to have a collaboration not only for various academia, but also industry and other people. So this is the main objective of blue economy, but the pilot project what I mentioned is that next one, it is a deep ocean mission. So the deep ocean mission is having a 6 vertical. Of course, India has targeted this basically the deep thing. This deep ocean means it is not a deep water mission. It is basically deep thinking, deep knowledge. That means we need to have more and more knowledge from the ocean. That is the idea, the deep knowledge. We need to explore deeply. And it is a pilot project of blue economy. Similar type of pilot project has been given to Ministry of Environment and Forest, and also shipping, also fisheries. Like that, each one pilot project has been given for the blue economy. Once the pilot projects are demonstrated value, then only the policy will come. That will become the bigger umbrella. That's the idea of government. So just I will briefly explain about what is the 6 vertical. So the vertical one is basically deep sea mining. As I mentioned that the mining, we want to do 6 kilometers, we have to vertical lifting of the minerals. So that we don't have a pump for that. So we need to develop that mining machine. Mining machine has been developed, but we need to have a pumping machine. That is now we can go there and like a bucket, like a well is there, you can bring in bucket, like a water you can bring it. But that is not economically what is called efficient. So we need to have a pump, like motor we are pumping. Like that we need to pump, then only it is economically viable. And the second one is underwater vehicles. We are developing various underwater vehicles and also manned submersible. You know that NIOT, National Institute of Ocean Technology, is developing through human being will go up to 6,000 meter deep. Already they have developed. Now by this year they will go for up to 500 meter. By next year they will go to 6,000 meter deep. That means basically it is exploration purpose. So these are the major 2 technology. Apart from that, there are underwater vehicles and other things. So that is why if any of you want to contribute in the underwater vehicles or any other mining or manned submersible, it is welcome. You can submit the proposal. We will be happy to work together. So basically the vertical one is technology to harness ocean resources, or maybe ocean exploration, you can say that. That is number 1. And the technology, the vertical 2 is ocean climate change advisories. Basically in this we want to project how our coastline will change in next decade, maybe next 50 years down the line, next century, how our coastline will, morphology will change, and what is the, what is called ocean warming is going to happen, and what is the, basically they use the models of various kinds and various observation system from the gliders, Argo and all various observation system they put it and model them, they assimilate them, then they try to forecast in the climate scale, next decade or maybe the much beyond scale. And also they finally they want to do how the Indian coastline morphology will change, and including various cyclone intensity will increase, various other things happening, how it will be storm surge and other things it has to be taken into account. And the third one is basically exploration and conservation of deep sea biodiversity. Basically we want to map the entire Indian Ocean region, what are the biodiversity exist, flora and fauna. Especially we want to start with what is called hotspot like sea mounts, seamount area, what are the flora and fauna exist, whether there is new species are available or new, what is called, but if the species are available, we want to document it. And also we need to, basically it is based on the taxonomy. And also we want to develop a biodiversity database and bioprospecting. And finally, we want to have a what is called marine, what is called protected area. They call MPR, marine protected area. We want to have like a climate goal. We are telling 2070 neutral, carbon neutral. Similarly, in the ocean, 2030, we want to have a 30% of the ocean, whatever is that we want to protect for the future. So which area to be protected? For that, we need to map the biodiversity. Suppose some spawning ground of the fishes or some coral reef or anything else is there, that area we need to identify. We need to protect that area so that at least 30% we need to protect. That's the aim. So basically, this vertical is basically to map the biodiversity and conservation aspect. And vertical 4 is basically it is a survey and exploration. Basically, it is to hunt the various non-living resources. So first you go with the sheep, then you go with the various autonomous underwater vehicle and try to find out the hydrothermal vents where it is in the mid-ocean. So we have recently found 4 such hydrothermal vent area because it is finding a needle in the very big ocean. It is very difficult to find out. First you have to find out mid-ocean ridge, then from there we have to have a passive traces, various chemical and geochemical analysis you do that, then you identify some area it is possibly likely, then that area you put a AUV as well as ROV and get the sample, then finally you identify, yes, this is a location available for hydrothermal sulfides. So we have identified 4 such sulfides, but now we are still exploring that. In this vertical, we are also building a new vessel. It is roughly about 100-meter vessel. It is a multi-vessel, means it can take care of seismology, it can take care of oceanography as well as atmospheric science. All the 3 we can, including radar, the Doppler weather radar and other things also will be in there. So this is already going on construction in Kolkata. Maybe next year it will be coming out. And the 5th vertical is energy and fresh water from the ocean. As I mentioned that we need to have a water-powered desalination plant along with the water. So water we need to, maybe we are looking at a 5 megawatt power and 5 mld water in one plant. So that is what we are looking at it. Basically, as I mentioned that economy, now we can produce this in the island, but not in the mainland. Because in the mainland, the cold water getting, I have to go far away from the ocean. In the in the island, you have a very 100-meter, you have a deep water. So that is a problem, but now we are looking at it in futuristic. Yes, now it may be economically not viable. Who knows, maybe 10, 15 years back, how this solar panel will revolutionize, we don't know that time. This is costly. Similarly, this also, I will come back to that, why we are, this is very important in futuristic. Because especially when you are going for a computer or a computational world, I think this is more and more important in that aspect. And the 6th vertical is Advanced Marine Station for Ocean Biology. So basically we are trying to develop a test bed for each state, one test bed, and we want to monitor all along the coast, and we want to have a 9 what is called infrastructure lab all along the coast. Each coast, one, that means each state, one lab. So they have to make a routine observation, because this observation is required for coastal monitoring, pollution, as well as various biological aspects we want to monitor. So that is why we are making it. And apart from that, we are also doing capacity building for the various oceanographers. As I mentioned that we are already making it every year roughly about 50 JRFs we are funding for CSIR. So that the net qualified people, they can choose for earth science, so that they can have an extra fellowship of 50 number. And similarly 25 postdoc, so for the ocean. So this we have made it so that more and more people we want to attract this. So that is what 6 vertical all about. And finally, when just I was telling blue economy, but we have other aspect, atmosphere. Atmosphere we want to go for better improve the weather forecast, but finally we want to go for weather management. Weather management means weather intervention. Whether we can have hailstorm is there, whether we can suppress or we can do any other intervention in the weather. And similarly, second one is the blue, as I mentioned, and polar. Polar also, it is a basically geostrategic aspect. So we want to have a leader and significant player in polar affairs. We have a station in Arctic, Antarctic, and Himalaya. All the three poles, how it is changing over the period under the climate change. And it is not only monitoring, but also basically for this polar region, science is the currency. Science diplomacy. So geostrategic aspect you have to do. There are many things are there in the polar regions which geostrategic importance. And also the last one is the geosciences. Basically, we want to have a early earthquake warning, whether it is possible from primary wave to secondary wave, the difference, whether make use of it few seconds before, at least you will be able to tell the earthquake secondary wave when it will come. So that is what we are looking at it. And also exploration of non-living resources in the land, and also some of the geological aspect, the curiosity-driven questions, whether we can answer it, some of the curiosity-driven questions. So for all these things, we want to observe, as I mentioned, that all the 5 spheres, we want to observe them, we want to understand them, and similarly, we want to model it, and then we want to have a product and services. So that is what I started with. We want to do the science, and do the science, and also the science you translate into the services for the benefit of society. So this is a efforts needed. Just last slide. Basically, we have a fortunate, the only ocean named after one country, it is India, Indian Ocean. But unfortunately, we are not doing justice to that, number one. And we have a bay in Bay of Bengal, we have a sea in Arabian Sea, we have ocean in Indian Ocean. So all the three we have, but we have not utilized fruitfully. We have not done justice. So what I feel is we need to have ocean that much amount, we need to have more effort. And also Arabian Sea amount, we need to have a sustainability. And the Bay of Bengal amount, we need to have an effort in mitigating various hazards from the various oceanic hazards and other things. So this is from AI. When I tell that some story to AI, I want to develop ocean energy in the ocean, and my supercomputer, quantum computer has to sit in the seabed, because the energy requirement in next few years, roughly about 25% of energy is required only for computing. So my computer has to sit in the seabed so that heat transfer or heat dissipation will take place in the seabed, produce the ocean thermal energy conversion in the sea, and also you put a lot of fish aggregation device, and also you can, if you are able to produce the energy and water, if you are able to utilize the energy inside the ocean, it is well and good. If you are not able to produce, since you have a fresh water and you have energy in the ocean, in the mid of the ocean, then always you can produce the hydrogen, because you split the energy with the fresh water, split it, you produce the hydrogen, you put a hydrogen tank in the seabed, whenever you want you can tap it. So that is what cartoon from AI generator. That's what we are thinking, that definitely in the future, already started in Vizag, now they are starting Google, already Google servers, it is available in the sea and the seabed. Now we need to go for what is called seabed resources. That time, only we can produce the energy in the deep ocean, but we have a problem, the energy to bring it to the shore, I have more costly, because the cable and other thing. But if I am able to produce there itself, by compute or anything, maybe I can use the quantum computer there, we can use weather forecast sitting in the sea, then that will be great. So that is what I am looking at it. So these are the overall objective, just a glimpse of blue economy, what are the opportunity and what are the challenges it is there. Just I want to highlight. So if you have any questions or anything, I'll be happy to answer. Thank you. Yes.
So in the Middle East, there is a water desalination plant everywhere.
Pardon?
In Saudi Arabia and all those countries, so how is that technology different than us? This is cheaper
You are
than
talking about desalination?
desalination.
Yeah, that's what I mean. Desalination, that is with reverse osmosis, brine.
Okay.
So you produce the brine. Okay. If every time you are producing the desalination of reverse osmosis, that brine will spoil your land. So that is why you should not keep your brine. And even if you put in the ocean also, that brine will be in the coastal. So that's why your coastal waters will be degraded. So that technology is not advisable
Okay.
as much as possible.
Just one more small question. So this thermal energy
Yes.
using for irrigation,
Yes.
is it because of convection which is driving that? How do you tap the thermal energy for electricity?
No, that's what. No, if you have a 20 water warm surface water is 28 degrees.
Okay.
Now water will boil at 100 degree,
Okay.
but at atmospheric pressure.
I see.
Okay. Now the atmospheric pressure you reduce, the 28-degree water will boil. That boiled water you take it, you send it through turbine, you produce the energy, and that extra, that evaporated water, you condense with cold water from the subsurface, then you will get water and energy. I think if anybody, if you are going to Lakshadweep, please visit our lab. They are producing 1 megawatt power in Kavareti. Both 1 million liter water and 1 megawatt power.
Very nice.
Yeah. Still, energy is not operational, it is going on. Maybe another 1 or 2 months it will take to complete.
So I read these reports that because of impact of climate change, ecology on the surface of ocean is changing significantly. So do we have like biodiversity repository as of now? And are there plans to have it monitored for coming years?
Yes. The Center for Marine Living Resources in Kochi, that lab mandate is that one.
Okay.
Because of the climate change, how the species diversification is happening and which species is depleting. Even for example, earlier you get a mackerel fish only in the west coast. Now it is getting the east coast because of the climate change. And second thing is, in the tropical species, whatever we have, that is now migrating towards in the mid latitude because of warming. Now the mid latitude species, it is going to the polar region. So that is why the polar region will be having more and more ecosystem rich in terms of protein.
Right.
So
right.
that is why we need to keep eye on polar region also.
Okay. And any comments on microbial ecology, because those are the bedrock of all the other things
Yes, yes.
in ocean.
So that's what the blue biotechnology, most of the people, of course, we have not done much. So that is why we have activated now, right from eDNA, microbial ecology, and all other things. They have started now various biotechnology lab, and maybe as I mentioned that there are 6 dozens of universities, various universities are working. So what we are doing is all along the coast, we are getting sample in a month, 1 sample at a time, same time. So that sample is collected at one place. They are looking at various states, how the microbiological aspect they are looking at.
Thank you.
So my question regarding the deep sea mineral resource exploration. So do we have like any sample repository to get the sample and done the research? Because we are having, like, we are far from the sea and we don't know how much exploration has been done, or we don't know
It is
the
available.
status.
If you want, you can approach the IMMT or CSR lab. Tons and tons of material lying there. If you are asking few tons, they will be happy to give. Or maybe you require for sample analysis or anything, you can get it. You just maybe you can get my email. You can send my mail. I can direct where you want to get it. It is in Bhubaneswar. It is.
Yeah, I know that.
Yeah. Yeah, that's what, of course, the overfishing, basically we are doing overfishing in the coastal waters, but underfishing in the deep water. That is why this policy, we need to have a more and more deep sea fishing. So that's why now the government in this budget has given a lot of what is called economic benefit, subsidy, as well as rebate, taxes, everything has been given to encourage them to go to deep. So because everybody is going with small boat and go to coast and come. So we have to encourage more and more deep sea fisheries. So, but of course it is universally sustainability we have to keep in place. They are fisheries resource, they are monitoring how much we are catching, whether we are within the sustainable limit. Of course we are very, very low in sustainable limit. Okay, we are not at all overfishing, we are underfishing. course. In many Europe, Norway, Sweden, most of the power has come by offshore wind energy. Offshore wind energy.
Some implication for the avian population, right? Because it's in the ocean and it's also in the near the coastal. So there is a lot of ecosystem of especially birds, marine birds and all.
It will not be that much. See, marine birds. See, basically, birds will not much in that area.
Okay.
So most of the thing, yes, there will be definitely some degradation will be there, but it will. It is. We are not occupying like a farm. One. So just it can avoid and go.
Okay, by proper site selection.
Yes. And we have to inform the various people also this once you install.
So some convenient ways by which hydrothermal energy could be vented out, like it is having a hydrothermal energy, that hydrothermal vents.
Yes.
So any technology or any sort of design that can be.
We are more worried about from the hydrothermal vents, whatever minerals are coming, that only we want to tap. That energy, how to use it, we have not attempted. Maybe you can think about some solution for that. Yes, it is 200 to 300 degrees centigrade water, that water. So, yeah, it is something we not thought about. I don't know. Maybe you can think about how do we use that energy. Yes.
Well, I want to know how exactly electric shipboard microgrids or electric ships are coming in future. What is the development? I wanted to know the current status from you.
Yeah, now of course internationally the green shipping. Green shipping is started everywhere. Now the Cochin shipyard already first one they have started green ship. They have built the technology from Indo-Norwegian collaboration. They have started. So now it is according to me for India it is go longer way because we have many things to chew before going for green shipping. So but still they have done. Of course when we are going for a Car-Nicobar port terminal, big one it is coming. That is a green ship port. They want to develop that way.
So sorry, I just wanted to know about the deep sea surface again. I heard that there are few submersibles which are being planned by the Indian government. Just wanted to know what is the state right now? Are they under testing, and when can we see like research vessels going to the deep sea surface in the Indian Ocean?
Yeah, NIOT has developed a deep sea submersible or human submersible. So 3 human beings can go dive up to 6,000 meters. That is our target. But presently we have a problem with titanium spear. So we don't have a titanium spear. We have a lot of restriction with various government. We cannot get the titanium spear. So now ISRO is developing this titanium spear for us. So it is a very slow process. But in the meantime, we are making it 500-meter depth we want to go. So for that seal spear we made it. But all other exostructure, everything is titanium. So what our idea is this year, by maybe second half, maybe last quarter, maybe September, October, we will be diving up to 500 meters. Already test everything is over. Even I went to up to 30 meters and drive and came. But we are not, beyond we are not able to go because of some other restrictions. And 500 meters we are planning to go for this year. And once that solid spear, the titanium spear is ready, then all that components will fit here. Then it can go to 6,000. Only spear is a restriction for that. That's why. So it will be by next year. We are fighting with Gaganyaan and Samudrayan. Samudrayan is go to 6,000 meters. Gaganyaan is go to space. So who will go first? That's what we are fighting.